Hello, my name is Zakel, and today I'm going to demonstrate how you can write a very simple, very basic falling sand simulator in about half an hour. This is going to be recorded in one take, so you are going to see all my thinking process and all my errors and all that kind of stuff. So, we are going to use a thing called the P5JS. It's like processing, but if you don't already know, processing is based on Java, and P5JS is like processing but for JavaScript. I often use it for very quick visual thing and that kind of stuff. So now let's begin. So the thing about falling sand simulator is that it feels like a very physical thing. Like if you only see the completed product, you will feel like, oh, there must be some kind of physical calculation involved. But no, it's all it uses the same principle as the game of life. So if you don't know game of life, it's like you have a 2D grid, and for each single cell of that grid, you calculate all the surrounding grids. If a certain cell has 4 or 5 or 6 cells around it that is alive, then that cell itself became alive. That kind of stuff. So the most basic falling sand simulation is, instead of writing that, you write that if the cell is a grain of sand and the cell directly below it is air, you move the grain of sand down one grid. That's one of the most basic rules of it. So it's all cellular automation. I'm not used to very much. So now let's begin. First of all, we will need a 2D grid. So the way we do 2D grids is like this. First, we define the size of the cell. We will say it's 20 pixels, and then we will define the size of the canvas. We'll define it in pixels instead of number of cells. Why? Because if we pin the size of the canvas in pixels, we can easily change the size of the cell and get a much larger grid within the same amount of area. I will show you about that after we finish this demo. Okay, so we can now calculate the size of the canvas in number of cells by doing this. So of course we will need some kind of data structure for storing the data of that 2D grid. And of course we will also need to change this canvas width and also changes the canvas width as well. And during the setup process, we will need to do this for let j for each row. And for each column, we will have a row, and for each column we push air in that row, and we will push the row into that grid. Of course, we will also need to define a few materials. We will say that air is 0, sand is 1, and wall is 2. And after that, we can now write the part of the drawing process. So for each row and for each column, we will say we will turn off we will say no stroke, because we will use the square function to write each single grid, and we don't need the border. So we will say let cell equals get from grid from X and Y, and we will switch on that cell. Okay, if it's air, we will say we change the filling color with white, and if the cell is sand, you say that it's some kind of dark green sand, and we will see that the wall is some kind of light gray wall. And after this, we can say that square at axis I multiply by the size of the grid, and the width of the square will be the size of the cell. Okay, so this will be our the drawing function. And of course, we also need a way to put in the sand. So we will define the mouse pressed callback for this. So this will be called whenever there's a mouse press event. So we will get the position of the mouse in the number of cells, like this, equals math floor mouse x divided by grid size, and that grid and for that we will say set grid at grid x grid. We will see that it's sand, and then we would also need to define get grid and get sand as well. No, sorry, set grid. You'll see that if the position is out of bound, we will return undefined, and we will say that return grid. We will do the same thing, set grid. Okay, so now if we run this code, we should see a white canvas, and on that white canvas, if we press our mouse button, we will see the grains of sand. J is not defined. Oh, there's spelling error. Okay, this is our first step. Okay, so how do we make it fall? The way we make it fall is that we do this. So before the drawing, we can say that the calculation happened, and for that calculation, we will say that for each row, and for each column, we will say run all the rule at position I and j. Now, here's the point. The way we are doing this is from left to right and top to bottom. This way is in conflict with one of the rules we are going to implement. So this is technically wrong. So I will show you in a minute. But before that, we are going to write the run rule function as well. We can also, before the run rule, we can also define a few auxiliary functions. So we can say that is err at x, y, it will return sorry, I'm used to Emacs, but now I can't use all the editor's properties. So now, when it comes to its wall, there is a little bit of difference. If we naturally, we will consider the border of the canvas as walls, and we also consider the material wall as walls. So instead of just saying that this is wall, we should also say that, or get rid is undefined. It's been a while since I write any JavaScript, so I might have made some error here. But we'll see. So now we are going to write our first rule. We will write something here as some kind of visual reminder of what the rules should be like. We will say that when there is a grain of sand and below that is a cell of air, the grain of sand falls into that cell. So we can say that if is sand at and is air at x, y plus 1, we will set it okay. If we run this code now, we will see that the sand accumulates at the bottom. We didn't see it fall. We didn't see the falling action. So why is that? The reason this happens is because how we calculate each state of the 2D grid. So like assume that at row 1 we will have some of this configuration. After calculating for row 1, we moved the grain of sand in row 1 to row 2. And after row 1, we start to calculate row 2, and we encounter the same grain of sand. And we move that grain of sand one step further down. So after the whole board is calculated, we continue moving that grain of sand all the way to the bottom. So that's what we are seeing here. One way to mitigate this is to calculate from bottom to start. From bottom to top. There are also other ways to deal with this, but this is to reverse the order of things is the most simple way. So to reverse this, we will say that from canvas grid and J should be what? J minus, and if we run this, we can see the falling action. So this is obviously not quite enough, because we don't want to see this kind of thing happen. We want to see that whenever a pillar of single grains of sand builds up too high, we want to see it collapse. So the way we do this is to add more rules. We can say that, we'll copy this. We can say that if there is a wall, at this part, and we will say that this grain of sand will fall into this place. We can say that if this, if we implement this new rule, we should be able to see that this kind of situation wouldn't happen at the left wall. So if we do this, we can also see we will now do this to the other side of the things. And we don't need to define our rules to be deterministic as well. We can write that if we have this kind of configuration, we can say that that grain of sand moves to the left or to the right randomly. So the way this will look is that is So and we will see that this would have this kind of formation. This is also not very good. We should be able to see that this thick pillar of sand to be collapsing. So there is something wrong with our rules. So obviously the culprit of this will be our rules to deal with sand when they are adjacent to some other materials. We should be able to say that when this kind of formation happens, all the things will collapse to left or right. So we can say that we can define a solid material as and we replace all the is wall with is. So as we can see, it kind of look like sand now. So let's go back to the cell size for a minute. The reason why I have decided to pin the size of the canvas in number of pixels is that we can easily do this. We can change the size of the cell from 20 to 5. We can immediately have this kind of things here. And of course, if clicking is too slow, we can change this to mouse drag, and this should give us this action. So now we are going to do a little bit more of it. So first of all, we are going to draw a cursor on this canvas. The way we do this is to first, of course, we will need to get the current position in numbers of cells, and we will say that stroke as 0, and after, and we will say that fill after this action, we should be able to see a cursor here. And if we change it back to 20, we should be able. And we can also add another parameter, cursor size. I need to check the reference about this because I don't have it all memorized. So we can say that we can change the size of the cursor with the mouse wheel. We can do this. Okay, we'll say that we need the event object, and if we delta and we can limit the size of the thing. And of course, the draw function needs to be updated as well. Is and we also need to write how we handle the thing. So we can have many different types, many different ways to deal with this kind of features. You can have many different ways to implement this feature. This is just one of the easiest way to do this. This should give us a proper working. Okay, this gives us this, and we can now write our code about walls. There is no rules about walls. You just put them on the grid, because normally they are not the kind of thing that will fall. Those are not the kind of thing that will be affected by the, let's say, pseudo gravity we are defining here. So what we can do is we can say that we can check if the we can say that if key is pressed, and if that key is A, we say that material is air. Else if key is, we say that material is wall. And after this, we should be able to see we should be able to draw walls and delete things because we overwrite it with air. So what we can do now is something like this. We can draw a container using the wall material. We can then put some sand into it, and we can open a hole in the wall, and all the sand will fall into the ground. We can also change the size of the grid so we can see it more clearly. So there you have it. Very basic falling sand simulation. I will put the link to this code about around here, and you can check it out yourself. So that's it for today. My name is Dakel, and I will see you in the next video.